No, Venkatesh, it's not a demo class. It's a regular class. It's not demo. Okay. Yeah, welcome you all for the GATE class funded by AICTE Prerana. Myself, Shivakumara, faculty in the Department of Civil Engineering, CMRIT. So today we'll discuss about structural engineering. That is section 2. If you see a GATE syllabus, section 1 it is mathematics, and section 2 it is structural engineering. So under structural engineering, different subjects will come. That is engineering mechanics, one subject. Solid mechanics, that is nothing but strength of materials you studied, no? That one. And then third subject it is structural analysis, both determinate and indeterminate structures, analysis of determinate and indeterminate structures it is included with. And fourth subject it is construction materials and management. Fifth one, concrete structure. Sixth one, steel structures. Totally 6 subjects are there under structural engineering, that is section 2. So in today's session, we discuss about engineering mechanics. The syllabus is like this. Under engineering mechanics, we discuss about a system of forces, different force systems. Okay. And free body diagrams, we discuss about how to draw free body diagrams before analyzing any structure. And then some problems on the same also we will discuss. And then next, equilibrium equations and some problems using equilibrium equations, that is a concurrent coplanar force system and concurrent non-coplanar force system, and coplanar non-concurrent force system also. Some problems we are going to solve by using equilibrium conditions. And internal forces in structure, this topic also we will discuss. Actually, when it comes to internal forces in structure, that is axial force, bending moment, shear force, torsion, all these forces normally the discussion topic will come. But shear force, bending moment, torsion, these topics comes in solid mechanics, that is strength of material. And under engineering mechanics subject, we deal only with the axial forces, determination and all will do as an internal force in. And we also discuss about friction and its applications. So some theoretical introduction and conceptualization, and also some problems we are going to solve under this topic, frictions and its applications. And the next topic, it is the center of mass, center of gravity, centroid. All these things we discuss under this center of mass. And then last topic, it is a free vibration of undamped single degree of freedom system. SDOF, single degree of freedom. I think except this free vibrations of undamped SUIF system, so all these remaining topics were covered in your first year subject, that is elements of civil engineering and engineering mechanics subject. Correct? Correct? It was covered. The response is important because I can't see this screen keep on seeing. Sometimes connection automatically we will lose. So if you speak in between, that is an acknowledgement for me that there is no connection problem. Okay. Whenever I ask you, please try to respond me. Okay. Only I can able to see that enlarge the screen. Are you able to listen to me? Am I audible?
Yes, sir.
Yeah. My voice is clear, no? No vibration? Hello?
It's clear, sir.
Okay. Yeah. So that is what we discuss under engineering mechanics. And then when it comes to solid mechanics, shear force and the bending moment magnitudes, we will determine of a statically determinate structure, that is a beam. And shear force bending moment diagrams also, how to draw, that also we'll see over here. And a simple stress and strain relationship and problems related to that. Stress and strain relationship problems we will solve. And a simple bending theory, flexural and shear stresses, shear center, uniform torsion, and transformation stresses also we will discuss about, and problems on the same we will solve. Buckling of column, combined and direct bending stresses also we will calculate. So I think whatever it is mentioned over here, everything was there in strength of material subject. Nothing was left. Everything is studied in this. We'll have to recollect it now. It was thought, right? Whatever it is mentioned over here. Hello. Hello.
Yes,
You can able to see this, right?
yes, sir.
Okay. And then both statically determinate and indeterminate structure analysis of statically determinate and indeterminate structure, both the subjects it is included over here, that is structural analysis. So statically determinate and indeterminate structures by force or energy method, and a method of superposition we will discuss about, and analysis of trusses by method of joints and method of section, and analysis of arches, that is the 3-inch arches we will discuss about, and we'll discuss about analysis of beams, cables, frames. Okay, all these things we'll discuss. Displacement method analysis method also we'll discuss, and analysis of indeterminate structure by using slope deflection method, moment distribution method. Okay, these things also will learn. Influence line diagrams, stiffness and flexibility matrix methods also we will learn under structural analysis subject. And next subject it is construction materials and management. So under construction materials, structural steel will discuss about what are all the chemical compositions a structural steel consisting of, and what are all the properties, its mechanical and physical properties also we'll discuss about, and its behavior under the application of load also we will discuss. And concrete constituents, that is the cement, fine aggregate, coarse aggregate, and water. These constituents also we'll discuss about, and then how to do the mixed proportioning, that is mixed design, and short term and long term properties of concrete. This one also we will learn. Okay, and when it comes to management, so type of construction projects, there will be different types: project planning, network analysis, PERT and CPM, cost estimation. So totally these many subjects I'll be taking. This concrete structures and steel structures will be handled by Professor Lakshmi. Okay. So construction materials management, structural analysis, solid mechanics, engineering mechanics. So under structural engineering, totally 6 subjects. Among that, 4 subjects are paid. Come for engineering mechanics subject, some introduction to start with. Uh, this subject basically it deals with the forces. Okay, the effect of a force on a body. So it is important to know the definition of force as we are dealing with the forces in this subject. What is the definition of a force? It is an external agency which will try to change the state of the body. Okay, at the state of rest or in motion. Okay, that body. This force will try to change that state. An external agency. This one is. So that disturbing physical agency, that is named as force. Okay, this will induce some uh, there is change in state, but however there will be resistance against change in state. So which is that resistance? That resistance is nothing but inertia. Okay, so inertia is developed by what? That is by mass. Okay, when it comes to force, its effect, how it is going to affect on body, that is related to mass and acceleration. Okay, so that's the definition. And then this mechanics, it is classified into statics and dynamics. So in dynamics, again, it is subdivided into kinetics and kinematics, where including the force which is causing the motion and excluding the force which is causing the motion. Based on that, it is divided into kinetics and kinematics. So first topic you come for under the subject engineering mechanics. That is, first topic is system of forces. So under system of force, yeah, there will be types of force system. What do you mean by system? System means more than system of force. Whenever we say, what does it mean? It is more than a single force. If there is more than a single force acting on body, you can call that as force system. Okay, we can't call a single force as force system. More than single force is there means that is a system of forces. So different type of force systems are there. So based on how many planes the forces are acting in, so that is we can divide into single plane, multiple plane. So single plane means coplane. In one single plane, the forces are lying means coplanar. If not, it is non-coplanar. Okay. So coplanar force system is one type of force system. If all the forces are acting in a single plane, we call such force system as coplanar force system. If not, if the forces are not acting in a single plane, multiple planes the forces are acting in, such force system is called as non-coplanar force system. Okay, so that is a second type of force system. And then third one, it is collinear force system. If the forces are acting in a single line, okay, in the same line of action, the forces are acting in, such force system is called as collinear force system. Again, whether if you extend the line of action of force, whether the line of action meet at one single point or not. So based on that, again the force system is divided into concurrent and non-concurrent force system. For example, here is a force system. It's acting on a rigid body. So that is F1, F2, F3, F4. Okay. So if you extend this line of action of F1, it will come like this. Some line will come. And if you extend this F3 like this, it will come like this. And if you extend this F2 like this, this line will go in this direction. And if you extend this F4, okay, the line will come like this. So the line of action of all these four forces are not meeting at one single point. If that is the case, this force system is called as non-concurrent force system. But if in case the line of action of all these forces are meeting what one single point means, such system is called as concurrent force system. Got it? Concurrent and non-concurrent. Okay. So we saw about coplanar and non-coplanar, and we also seen about concurrent and non-concurrent. Now let us combine the both coplanar, concurrent, coplanar, non-concurrent, non-coplanar, concurrent, non-coplanar, non-concurrent. You are here combining both plane and point of concurrency. The force system is coplanar concurrent force system. That means all the forces acting on the structure or a body are lying in a single plane. And then concurrent means all these forces, if you extend the line of action, these forces will meet at one single point. its line of action. Okay. If the type of force system like this, we call that system as coplanar concurrent force system. Okay. And the next one you go for coplanar non-concurrent force system. Yeah, Jai Surya, what does it mean? Coplanar means
Sir, forces are acting in the same plane.
same plane. Pranati, what does it mean? Non-concurrent?
They are
Pranati?
not, yes, sir.
Yeah.
They're not in the same direction, sir.
They are
Not in the same direction.
not meeting at one single point.
Yeah, point.
Okay. If there is a force system where all the forces are lying in single plane, but if we extend the line of action of forces, they are not meeting at one single point. Okay. If such force system is there, we call that force system as coplanar non-concurrent force system. Okay. And then another force system, it is coplanar parallel force system. So in this case, coplanar means all the forces are lying in single plane, but force system is it is parallel. Okay, each force are parallel to each, and magnitude of force is same. Diagrammatic representation of coplanar concurrent force system you can see over here. The line of action of F1, F2, F3, F4 is meeting at one single point, so that it is concurrent, and all the forces are lying in one single plane. That is xy axis to be mentioned in this. Okay, that is coplanar concurrent. This is a coplanar non-concurrent force system. See over here, if you extend this F1, F2, F3, F4, they will not meet at one single point anywhere. Okay, this is the diagrammatic representation of coplanar non-concurrent force system. And this one it is, when it comes to coplanar parallel force system, this one can be subdivided into again like parallel force system, unlike parallel force system. In case of like parallel force system, all the parallel forces are directed towards same direction. Here, F1, F2, F3, F4, all these forces are directed vertically upwards. Okay, so this system we call it as like parallel force system. If in case this direction of F2 was towards down, then this force system would not be a like parallel force system. It would be unlike parallel force system in such case. That is what the example given below. Okay, F1 is towards up, F2 is towards down, F3 towards up, F4 towards down. So all are parallel to each other, but direction of F2 and F4 is in opposite direction to the direction of F1 and F3. So this is also parallel force system, but this is unlike parallel force system. So whenever it comes to parallel, provided the magnitude of all the forces is same. Okay, these two are the diagrammatic representation of coplanar parallel force. And when it comes to non-coplanar, again the same thing. Whatever it is shown for the coplanar, in place of coplanar, we will put non-coplanar for all this system. Okay, here we had mentioned coplanar concurrent, coplanar non-concurrent, coplanar parallel. So in place of coplanar, now I'll put non-coplanar. Non-coplanar concurrent, non-coplanar non-concurrent, non-coplanar parallel. Okay, so that is why another system of force classification: non-coplanar concurrent force system, non-coplanar non-concurrent force system, non-coplanar parallel force system. Okay, so first one, when it comes to it is non-coplanar, it is mentioned. Srinidhi, what does it mean, non-coplanar? Is there, Srinidhi? Is not there? Okay. Chandana? Chandana?
Yes, sure.
Hello,
Yes,
Chandana.
sir.
Yeah, non-coplanar means? Non-coplanar means? What does
In
it
which
mean?
forces are acting in different planes.
Different plane. And concurrently?
Same plane.
Concurrently?
Forces are acting in
The line of action
the
forces are
same
meeting
plane.
at one single. Okay. So non-coplanar concurrent system. So forces are lying in a different plane. Put it in use mode. Forces are lying in different planes, but the line of action of forces are meeting at one single point. And then another system, it is non-coplanar, non-concurrent. Nisarga?
Yes, sir. The forces
Non-coplanar.
are acting, more than one single plane, but the line
Yes.
of action, the forces are meeting more than one point or passing through the more than one point.
We can't say more than one point. They will not
Or
meet at one
single
single
plane.
point.
Okay, sir.
Okay, fine, good. So this is what the force system, different force system, and some of the examples. Let us see some examples for these different force systems. Yeah, here coplanar concurrent force system. So in this analysis, you take one truss as an example. If you consider a joint over here, that is joint B, okay. So if you consider a joint B over here, how many members are connected at joint B?
3.
Three members are connected. So each member is subjected to it may be compression or tension. So all the forces are axial forces over here. So it can be compression over here, here, or tension over here or here. Okay. But if you extend the line of action of these compression or tension forces, they will meet at one single point at P. So that it will become a concurrent. It will become concurrent. And if you consider this as a two-dimensional truss, so all these forces will lie in single plane. They will lie. They will lie, right, in single plane.
Yes, sir.
Yeah. So this truss, when you consider a joint, okay, that will become coplanar concurrent forces. Okay, that is one simple example. And then when it comes to coplanar non-concurrent force system, forces lying in a single plane, but they are not meeting at one single point. So see over here, there are two plates. Okay, we are applying a force P over here on this, and we are applying force in this. Here, see the eccentricity E, which is mentioned over here. If you extend the line of action of P, and if you extend the line of action of P, they will not meet at one single point. But both P, they are in single plane. So it is coplanar, but it is not concurrent. So it is non-concurrent. And another example, simply supported beam. So in simply supported beam, you see horizontal reaction, vertical reaction at hinged support A, and vertical reaction at roller support B, and inclined forces are acting on B. So all these forces are lying in single plane. Okay. But if we extend this inclined force, if we extend this HA, VA, VB, and this inclined force, all these forces will not meet at one single point. So this force system will become coplanar because all these are lying in single plane, and non-concurrent because they will not meet at one single point. So these two are the examples for coplanar non-concurrent force. And then next one you come for non-coplanar concurrent force system. Simple example, it is tripod stand. Non-coplanar means forces, they are not lying in single plane, but they will meet at one common point. Okay, their line of action. So tripod stand, all of you have seen, right? And I have used also. Tripod
Yes.
can be used for this dumpy level, auto level, theodolite, or total station. All these instruments, normally this tripod will use to support it, right? Okay, the force in each member. Okay, if you extend this reaction force developed in each member, they will meet at one single point, so that it will become concurrent, but they will be in different planes, so that it will become non-coplanar. So this is one example for non-coplanar concurrent force system. And some other examples also, fluid flowing in a funnel, that will also become an example for non-coplanar concurrent force system. So all the fluid particles will try to pass through this slot, right? And they are forced towards this direction due to gravity force. But three-dimensionally, they will be flowing inside, so that it will become non-coplanar concurrent. And then fourth one, you come for non-coplanar non-concurrent force system, a framed structure. If you take a framed structure, beam, column, slab, and all, over there, forces will not lie in single plane, and they will not meet at one single point also. So this is an example for non-coplanar, non-concurrent. So that's it. This is what some introductory part for understanding the force system, different force system. Okay. So is it fine? Any doubts in this system of forces?
No, sir.
Okay. So we dealt with coplanar, non-coplanar, and we also dealt with concurrent, non-concurrent. So combination of both coplanar concurrent, coplanar non-concurrent, non-coplanar concurrent, non-coplanar non-concurrent, and then collinear force system, parallel force system. Totally 6 different type of force system with examples we discussed here. So next, before going to free body diagram, some for equilibrium equation, or let's see. For equilibrium equations, the resolution of force is required. No? Yeah, resolution of a force, you see. So before going to learn about a free body diagram and equilibrium conditions for solving the problems, it is important to learn how to resolve a force. Okay, if the force is in horizontal, well-defined coordinate direction, that is horizontal or vertical direction, or in the direction of analysis or requirement, not necessary to split the force, but it is not mandatory that a force should be in the same direction what we expect. Okay, force may act in any direction. For the analysis purpose, normally what we do, we will split the force into and make it multiple components of the force we will take. Okay, to simplify the problems for analysis purpose. For example, over here, there is a force of magnitude F. So this F inclined at an angle of theta with respect to horizontal, and which is acting in this direction. Here we can split this force into horizontal, that is in direction AD, and vertical in direction AB. Okay, Fx, it is the component of force F in x direction, and Fy is the component of force in y direction, Fx and Fy. So one right angle triangle formation you can see over here. If you take this theta and the trigonometric function, if you use cos theta, so cos theta is adjacent side by hypotenuse, that is AD divided by AC, where AD is Fx and AC is F. So cos theta will be equal to what? Fx by F. So the horizontal component of F is Fx equal to F into cos theta. So this is what the horizontal component of this force F inclined at an angle of theta with respect to horizontal. And the vertical component will be, so this is vertical component, right? That is CD, which is nothing but AB. So sine theta, sine trigonometric function you take, sine theta will be opposite by adjacent. Opposite is CD, hypotenuse is AC. So CD, it is nothing but AB. So we can write Fy. Sine theta equal to Fy by F. So Fy will be equal to F into sine. So horizontal component of F, that is Fx equal to F cos theta, and vertical component of F is Fy equal to F sine theta. So Fx and Fy, whatever these splitted parts, okay, their effect will be same as F on the body. Okay, whatever the effect was there by one single force F on the body, it is same as the effect caused by Fx and Fy together. This is how to resolve a force, single force, which is required for solving problem. And not only splitting, we can also combine the different forces. Okay, that is nothing but composition of forces. Combining different number of forces, and replacing that system with a single force system, it is possible. So that single force is termed as resultant force. Okay. So the procedure, it is, so there are multiple forces. Example, illustration you can see, that is figure number 2.6. This is figure number 2.6. There are different forces are there, that is F1, F2, F3, F4. So totally 4 forces are there. So you want to combine all these forces and want to have a single resultant force. So that single resultant force will induce the same effect as that this system is inducing. That is combiningly F1, F2, F3, F4, whatever the effect it is causing on body, the same effect will be caused by a single force, that is nothing but resultant force. Okay, so that procedure, how to replace that system is with the single force is. So this is F2, which is acting truly vertical, not necessary to resolve. F4, it is acting truly horizontal, not necessary to resolve. There is F1, which is acting at an angle of theta 1 with respect to horizontal, and F3 acting at an angle theta 2 with respect to vertical. So these two forces we need to resolve. So F1, if we resolve, the horizontal component will be what? What will get horizontal component if we resolve this? Jay Surya?
Sir?
So what is the horizontal component of this F1 if we resolve?
That's F1 cos theta 1.
F1 cos theta 1 we will get. So how about this F3? What is the horizontal component of F3?
F3 sin theta 2.
Yes, exactly, very good. So horizontal component of F3 will be F3 sin theta 2, and horizontal component of F1 is F1 cos theta 1. and vertical component will be F1 sine theta 1 over here, and here F3 sine theta 2. So that is how to split this single force F1 and single force F3 into vertical and horizontal components. So we have split it, and then now you can take algebraic sum of all the forces in horizontal direction and algebraic sum of all the forces in vertical direction. And here the sign convention, it is important. So towards down, if the force is directed, you take it as negative. If it is directed towards up, take it as positive. And with respect to horizontal, if it is directed towards right, you take it as positive. If it is directed towards left, you take it as negative. So now you come for a summation of effects. That means X means I refer to all the horizontal force. Sum of all the horizontal force if we take, so first we should consider the horizontal component of F1, that is F1 cos theta 1. So what is the direction of F1 cos theta 1, Nisarga?
So positive, sir.
No,
Horizontal side.
what is the direction? Towards right or towards left?
Towards right, sir.
Towards right. So it must be positive, right?
Yes, sir.
Yeah, good. So what is the, and then, so it is done. So it is positive as said by Nisarga. So it is the F1 cos theta 1 towards right. So that is done. And then you come for F2. There is no horizontal component of F2, so not necessary to consider. And then you come for F3. So there is horizontal component of F3, that is F3 sine theta 2. So what is the direction of F3? Venkatesh? 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 Are you there? Venkatesh is not there. Yes, Jaisurya.
Sir,
So what is the direction of F3 sine theta 2?
it's towards the left, sir.
Towards left. So what
It's
is the sign
negative.
convention? It's negative. So it is minus F3 sine theta 2. And then you come for F4, it is truly horizontal, so it is F4. Okay. So now you come for the summation of fx, you can have a look. F4 towards right, positive. F1 cos theta 1 towards right, positive. F3 sine theta 2 towards left, negative. So in the same manner, we come to vertical forces. F2 is acting towards down, negative. F1 sine theta 1 towards down, negative. F3 cos theta 2 towards down, negative. So that is what algebraic sum of all the forces in vertical direction, minus F2 minus F1 sin theta 1 minus F3 cos theta 2. All forces are directed towards down. Okay. So after finding this summation of Fx, summation of F5, you can calculate a single force which will induce the same effect. So that is formula R equal to root of summation of Fx square plus summation of Fy square. So this is the magnitude of resultant force or single force which will induce the same effect as that of this system is inducing on body. And then direction of this resultant force, if you want to determine, you can use theta equal to tan inverse of summation of Fy divided by summation of Fx. So by using these two formulas, the magnitude of resultant and direction of resultant can be determined. Okay. So the procedure how to determine the magnitude and direction of resultant, that is composition of forces, is that. And then for solving problem, some concept of moment of force also it is required. So before that, before going to this topic, let us try to solve one single problem on how to calculate or how to do the composition of forces of coplanar concurrent forces. You are here? To have a look on the candidates for all that. what type of force system this is? This one. So there is a x-axis, there is y-axis. 100 Newton, 200 Newton, 200, 275, and 250. Totally 5 forces are there. So what type of force system this is? Taruni? 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 Ruchita?
Yes,
Are you
sir.
people listening?
Sir,
Yeah. What type of force system this is? This one. Can you able to see this diagram?
yes, sir. Coplanar,
So what type of force? Yeah. Coplanar.
non-concurrent.
Coplanar. It is non-concurrent.
Sir, sorry, sir.
Is it non-concurrent?
It's not point
See over
two.
here. This point you see? The line of action of 200, 200, 100, 275, and 250. So the line of action of all these forces are meeting at one single point, right?
Yes, sir.
So it is concurrent.
Yes, sir.
So this force system is
Coplanar, concurrent.
concurrent force system. Yeah. So now for doing the composition of all these forces and for determining the resultant of this system of force, we need to determine, we have to resolve the forces and we need to determine the summation of forces acting in horizontal and the summation of forces acting in vertical direction. So let us start to resolve the forces first. So there is 100 Newton force acting at an angle of 45 degree with respect to horizontal. So if we resolve this, the horizontal component of this 100 Newton force is Pavitra.
Yes, sir.
Pavitra. So what is the horizontal component of this 100 Newton force?
100 cos 45, sir. Positive.
Yeah, good. And then Pranati, what is the vertical component of this 100 Newton force? Pranati?
Yes, sir.
Yeah, what is the vertical component of this 100 Newton force?
200 sine 30 positive.
100 Newton
Oh,
force. I'm
100.
asking you.
100
Yeah.
sine 45. Sir.
Yeah, it is 100 sine 45, positive or negative?
Positive.
Positive. And then horizontal component of 200?
200 cos 30.
Are you sure?
No, sir. 200 sine 30, sir. Positive.
Yeah, because angle, it is with respect to y-axis, right? 30 degree.
Yes, sir.
So cos will be in this direction, sine will be in this direction. Okay.
Yes.
So this is 200 sine 30. And then vertical component of 200 is?
200 cos 30.
Okay, good. Janardhan Chari, what is the vertical component of this 200 Newton force? Janardhan Chari? Janardhan Chari. Pooja JV?
Yes, sir.
Yeah, what is the vertical component of this 200 Newton force?
Sir, 200 cos 30.
Yeah, and horizontal component is?
200 sin 30.
Yeah, what is the horizontal component of 275 Newton force?
So 275 cos 6 degree.
6 degree. Good. Vertical component is?
275 sin 6 degree.
Yes, good. Yeah, Jamuna, what is the horizontal component of this 250 Newton force?
Horizontal component, sir.
Yeah, 250 Newton force.
Minus
Horizontal.
250 sine 20 degrees, sir.
Good. And vertical component is?
Minus 250 cos 20 degree.
Yes, very good. So there is no issue with the resolution of force. So all of you said correct answers, right? So now the horizontal component summation I'll come for. So plus 100 cos 45 plus 200 sine 30 minus 200 sine 30 minus 275 cos 6 minus 250 sine 20. Is it clear?
Yes, sir.
Yeah. So if you do the computation, you will get minus 288.287 Newton. That is summation of Fx value. Then you come for summation of Fy value 100 sine 45, 200 cos 30, that is plus 200 cos 30 minus 275 sine 6 minus 250 cos 20. Is it clear? Is it clear?
Yes, sir.
Yeah, if you do the computation, you will get 153.452 Newton. That is summation of Fy. So we are done with summation of Fx and summation of Fy. Just you need to substitute this 288.287 and 153.452 in this expression, that is R equal to root of summation of Fx square plus summation of Fy square. If you do so, you will get a single resultant force. It is 326.584. So this is the magnitude of single resultant force. And the direction of this resultant force, if you want to calculate, so that is with respect to horizontal axis, you should use this formula theta equal to tan inverse of summation of Fy by summation of F. So that is 153.452 divided by 288.287. You will get theta equal to 28.02. So this is how to calculate the magnitude and direction of coplanar concurrent forces. So with this, I would like to show you one simple problem which was asked in GATE like this. The same type of problem. Yeah. See this problem. It was asked in GATE 2016. See this problem, all of you. For the system of forces shown in figure, the value of resultant and the angle made by the resultant in x-axis is. The GATE 2016 question this is. So totally how many forces are here? How many number of forces are there?
3.
Three number of forces.
3.
100 Newton, 150 Newton, 200 Newton. And the direction also it is given 45 degree, 60 degree, and this one it is given as 15 degree. Okay. So remaining thing you need to calculate. So resultant force you will have to calculate. So what you will do first for solving this problem? You will resolve all the forces, right, with respect to horizontal and vertical axis. So this one it is already given, that is x-axis. So perpendicular to this x-axis, you can take y-axis in this manner. Okay. So with respect to this x and y-axis, horizontal it is 100 cos 45, vertical 100 sin 45. And this one, if you draw vertical over here, so this is 45 degree, and overall angle between 150 and 100 it is given as 60 degree. So if you draw a vertical axis over your y-axis, so total angle between x and y-axis should be 90 degree. So already 45 is remaining is 45. You will understand. So 45 minus 60 if you calculate, so remaining will be 15 degree, where this 150 Newton is made with vertical axis y. So 15 degree here it will come. So that if you resolve this, 150 cos 15, 150 sin 15. Okay. So over here already it is given 15 degree. You can resolve this. So same procedure, right? Simple, right? Is it the same type of problem? Hello?
Yes. Yes.
Yeah. So that's what about coplanar concurrent force system. One simple problem I have. So in the same manner, for a different type of problem, you can apply the same procedure. So now, next topic you come for moment of force. So what do you mean by moment, Jayasurya? Moment of force.
So the moment is force times the perpendicular distance.
So that is the mathematical definition. That is correct. Force times the perpendicular distance from where? From where to where?
The line of action of the force to the point where we acquire the moment.
Yeah. About which point we are trying to find the rotational effect of the force from that point to the line of action of the force. So that perpendicular distance we are going to multiply with the magnitude of force F. Okay. So basically the definition of moment, it is the rotational effect or turning effect induced by the force on the body. So that is known as moment of force. That is turning effect. So mathematically for calculation, how we will calculate this? See, there is a rigid body and a magnitude of F, the force is acting. And we want to calculate the rotational effect induced by this F about this point. So if you want to calculate, we'll have to multiply F with T. Okay. So with respect to T, if we hold this firmly, if we push this object in this direction, this body or the object will try to rotate in which direction? Will try to rotate in which direction? If you hold over here and if you push this body in this direction with magnitude F, this body will rotate in Jamuna? Yeah.
Clockwise, sir.
Clockwise direction. So you can like sign convention, you can take this clockwise as positive and anti-clockwise as negative. Okay. So over here, if you take moment center over here, we are applying force in this direction. This is the perpendicular distance D. Apply the force and it will try to rotate in which direction? Anti-clockwise direction. And the magnitude of moment is F into D. F, it may be in terms of Newton or kilonewton. D may be in terms of mm or centimeter or meter. So kilonewton and then this one meter. What is the unit of moment then? If you multiply F and D, kilonewton meter. Or it can be Newton. So that is what moment is. And Varignon's theorem of moment, the definition of this, it is useful even in center of mass. That concept also, this topic is required. So do you remember Varignon's theorem of moments? What is the definition? Nisarga? Any idea? Varignon's theorem, what it says? Nisarga, are you there? Hello? Am I in connection? Any issue with connection?
No, sir.
Okay. I'm audible, right? Nisarga?
Yes, sir.
Yeah, can you hear me?
Yes, sir. Yes, sir.
Yeah. Varignon's theorem, have you heard?
Yes, sir. I think so.
What does it say? So what it says is the algebraic sum of moments of individual forces of a force system about a point is equal to the moment of their resultant about the same point. For example, see this sketch. Another problem I'll take. Yeah, see this problem. Yeah. So totally how many forces are acting in this grid? 250 Newton, 150 Newton, 100, 400, and there is a 3 Newton meter moment, 200 Newton force in this direction. Correct. So totally 1, 2, 3, 4, 5. 5 forces and 1 moment, that is 3 Newton meter. Is it concurrent or non-concurrent? This force system, is it concurrent or non-concurrent?
Non-concurrent.
It is non-concurrent force system, right? So it is a non-concurrent force system. If we take a moment of all these forces about one single point, say for example, I am taking moment of all these 5 forces about point O. Okay. So according to Verignon's, whatever it is stated, that is moment of each individual forces about a point. Okay. So which is that point? A point means that is O. I am taking moment of all these forces about O. So that magnitude will be equal to the moment of all these forces resultant, that is R. Okay, moment of all these forces resultant about the same point. That means this R into perpendicular distance D. So whatever it will come, so that is equal to moment of all these individual forces. So that is what Verignon's theorem of moment says. Can you repeat? Pranati, Verignon's theorem. Pranati,
Yes, sir.
can you repeat Verignon's theorem?
I couldn't listen properly, sir. There is little disturbance that side. That's why.
So what
Hello.
Verignon's theorem says is, if we take a moment of all the forces acting on an object about a point, so that magnitude will be equal to moment of their resultant about the same point. Their resultant, I am telling. Their means which are all those each individual forces I said, no, these forces resultant. Okay. So that is some information about Verignon's theorem. You can read it, all of you. All of you can read this statement once. Can you read? Verignon's theorem, it states that the algebraic sum of moments of individual forces of a force system above a point, okay, so that magnitude is equal to the moment of their resultant about the same point. Done?
Yes, sir.
Yeah. So now you come for calculation of resultant force of coplanar non-concurrent force system. So coplanar concurrent, one problem you saw how to solve it. So when it comes to coplanar non-concurrent force system, yeah, let's start from here. Problems on coplanar non-concurrent force system. There is a simple problem over here. A rigid plate A, B, C, D. It is subjected to forces as shown in figure. Compute the magnitude, direction, and line of action of the resultant of system with respect to point A. So with respect to point A, they are asking, so what is the magnitude of resultant force for given system of force, and what is the direction of this resultant force, and what is the line of action of this resultant force. The line of action, that means the location of this resultant force with respect to point A, they are asking you to determine. So in this figure, by looking at this, so what is representing the location of resultant R over here? This D is representing. So D is saying the location of R is at a distance of D from A. Got it? So you forget this. Later at the end, you will have to look at this. Now you concentrate on how many number of forces are acting on this plate. So totally 1, 200 kilonewton force, 100, 2, 200, 3, 100, 4. So totally 4 number of forces are acting on this plate. Okay. So what type of force system this is? Coplanar? Concurrent?
Non-concurrent.
Yeah, coplanar non-concurrent force system. So what is the first step to determine magnitude of resultant R?
Resolving.
Resolving the forces. Resolution you know. So 200 at an angle of 30 degrees. So that horizontal component of this 200 is 200 cos 45 and vertical component of this 200 is 200 sin 45. And then this 100 kilonewton you come for, it is already in horizontal direction only, not necessary to resolve. You come for this 200 kilonewton with respect to horizontal, it is 45 degree. So if you resolve this, horizontal component is 200 cos 45 and vertical component is 200 sin 45. And then this 100 kilonewton is already towards down direction. So Jamuna, you tell me what all I have to write for summation of fx.
Summation of fx, sir.
Yeah.
Plus 200 cos 30 degree.
Correct.
Plus 100.
Correct.
And minus 200 cos 45 degree.
Very good. And you tell what all I have to write for summation of fy.
Plus 200 sin 30 degree.
Yeah.
Then minus 200 sin 45 degree and minus 100 kilonewton.
Very good. So if we do so, we will get 131.78 as summation of fx minus 141.42 as summation of fy. So you know the formula R equal to root of summation of fx square plus summation of fy square. You will get 193.30. And then direction of this resultant is, so theta equal to tan inverse of summation of fx divided by fy divided by summation of fx. So that is 141.42 divided by 131.78. You will get 1.703. Theta equal to tan inverse of 1.703. You will get 42.02 degree. It is not necessary to carry this negative sign convention. So by looking at a sign convention of this summation of fx and summation of fy, we can decide the direction of resultant force and also the quadrant. So now we are done with the calculation of magnitude and direction. What is third question which is asked over here? Magnitude is done, direction is done. What else we should determine? Darshan?
Yes, sir.
What else we should determine? Magnitude is done, direction is done.
Line
Value
of
of R.
action. Resultant, sir.
So line of action we should determine, right?
Yes,
That is
sir.
nothing but the location. So how we can determine the location of R? Any idea?
So moment.
Yeah.
So by finding out momentum, sir.
Momentum, by finding momentum. Pranati, any idea? How we can
Yes,
find
the resultant.
Sorry?
The sum of moment of all the forces
Yes, yes,
according to Varignone's theorem.
yes, very good. We should use a Varignon's theorem over here. So we should take moment of all these forces about which point?
Uh,
So much of disturbance is there, Pranati. Yeah, Jaisurya, we have to take moment of all the forces about which point here?
So the reference point A.
Reference point A, because we have to locate the resultant with respect to A, right? So we
Yes.
should take a moment of all the forces about point A. So that should be equated to what, Jaisurya? So moment of all the forces will take about A, right? So that should be equated to?
0.
No, why do you equate it to 0? You have to determine this D, right? That is location of R. So what Varignon's theorem says? The moment of all the forces about a point in a rigid body, it is equal to moment of the single resultant force about the same point, correct?
Yes, sir.
So you should equate it to
R times D.
R times D. Okay, so that is what we are doing over here. So resolution, it is done. So 100 kilonewton force, it is the line of action is passing through A. Any rotational effect will this 100 kilonewton force will cause about A? Will
No.
it cause? No, it will not cause, because the line of action is passing through A. You come for a 200 kilonewton force. Horizontal component is 200 cos 30. So what is the line of action of this 200 cos 30? It is AD, right? The line of
Yes.
action of 200 cos 30. So will it induce any rotational effect?
No.
No. The vertical component of this 200 kilonewton, 200 sin 30. Okay, it is this vertical component. And what is the perpendicular distance?
1 meter.
1 meter. So what is the direction of this 200 sin 30? Is vertically upwards, no?
Yes, sir.
So vertically upwards means if we hold this point A firmly and if we apply 200 sin 30 towards R, how this object will rotate?
Anti-clockwise.
Anti-clockwise. So 200 sin 30 into 1 meter. So what is the sign convention for this term?
Minus.
Minus. So minus 200 sin 30 into 1 meter. So that is the vertical component. And then you come for 100 kilonewton. So the line of action, it is BC. And what is the perpendicular distance from this line of action to A?
1 meter.
Again 1 meter. Which 1 meter that is? Here it is meant to be.
CD.
So this 1 meter. And if we firmly hold at A, and if we pull this object in this direction with 100 kilonewton force, so what is the direction of rotation in such case?
Clockwise.
Clockwise. So 100 into 1, the sign convention for this is plus.
Plus.
Next you come for this 200 kilonewton. The vertical component you consider first, that is 200 sin 45. So what is the line of action of 200 sin 45?
AD. Sir, AB.
AB. So will it induce any rotational effect?
No.
No, because the line of action of 200 sin 45, it is passing through A. No rotational effect. So that is 0. You come for this horizontal component, that is 200 cos 45 towards left. And if you hold the point A firmly, if you pull this object with a force 200 kilonewton cos 45 in this direction, what is the direction of rotation?
Anti-clock.
Anti-clockwise. So it is minus 200 cos 45. So totally how many terms will come for a calculation of moment here? One from 200 kilonewton, one component from 100 kilonewton, one component from 200 kilonewton. Totally three components. So let us see that in determination of location, the summation of moment at A, this is 0, this is 0, not necessary to consider, minus 200 cos 45 into 1 meter, 100 into 1 meter plus and minus 200 sin 30 into 1 meter. Only 3 terms. Remaining 3 terms, they are getting multiplied with 0 used to here. There is no perpendicular distance for these components. So if you calculate, you will get summation of a moment about A as minus 141.42, and then you equate that to product of resultant and D. Summation of MEA equal to R into D. So that D will be equal to summation of MEA divided by R. If you do so, what you will get? The perpendicular distance as 0.732. So this is the location of resultant force from point A. Resultant R is located at a distance of 0.732 meters from A. So that is the shortest distance from line of action R to point A. Any doubts? How to find location of resultant by using Varignon's theorem?
No, sir.
So simple use of Varignon's theorem. See, in GATE examination, they may not ask you to completely solve the problem like this, but in this they may split the problem. They may ask you to find directly the location of resultant force by providing the values summation of fx and summation of fy, or resultant and the magnitude of resultant and direction of resultant. They may mention and they may ask you to calculate the location of resultant direction. They may split. Okay, so nowadays, like pattern of GATE examination, right? Question pattern. Initially, it used to be MCQs, but nowadays it is not at all like that. With MCQs, fill up the blanks. So many fill up the blanks questions also coming. Okay, you may not be given the options. You may be given some dashes. You may have to calculate and fill the answer. Whatever you get like this, it is 0.732 you got. That value you may have to enter in the dash. Okay, you come for the syllabus. Equilibrium equations you come for. So we got to know how to calculate the resultant force, its direction, location, and all. Equilibrium conditions. Yeah. So under equilibrium conditions, for different force system, there are a different number of equilibrium conditions. For coplanar concurrent force system, summation of fx equal to 0 and summation of fy equal to 0. Two conditions of equilibrium you may get. It is sum of all the forces in horizontal and sum of all the forces in vertical direction equal to 0. But where in case of non-coplanar concurrent force system, you will get three conditions of equilibrium. Non-coplanar means you may go to three-dimensional summation of fx, summation of fy, and summation of fz equal to 0. And in case of non-coplanar, non-concurrent force system. So non-concurrent, whenever it comes to, moment comes in that case. Okay, summation of moment equal to 0 also, an added number of equilibrium. So two types of problems will solve under this equilibrium of forces. Under coplanar concurrent force system we will solve, and another is coplanar non-concurrent force system also we will solve. Yeah. So what is the definition of equilibrium? Harshan? Harshan?
Yes, sir. All the forces is equal to 0, sir.
All the forces are equal to 0, or it's their net effect equal to 0?
The net effect.
Forces will not
So
become 0.
in one point, all the forces acting at one point
Hmm.
is summed equal to 0, sir.
Fine. Whenever a body is subjected to, or an object is subjected to number of external forces, if the body remains be at the state of rest, if it was initially at rest, our body tries to move with a continuous acceleration, with the same acceleration, if it was initially moving with the same acceleration. So if that is the case, we can say that body is under equilibrium. Okay, so there will be no change in the state of the body. That is equilibrium. And different conditions of equilibrium, that is summation of forces equal to 0 and summation of moment equal to 0. Depending upon a number of planes, the summation of forces equal to 0. Under that, different direction forces summation will come. That is summation of fx equal to 0, summation of fy equal to 0, that is horizontal and vertical direction forces. Okay, so for coplanar concurrent force system, you come for coplanar concurrent. You see concurrent, right? So whenever the word concurrent you see, will there be any rotational effect in such cases? Concurrent force.
No, sir.
Why?
It will be
Because
acting at the same, in the same line of action.
At a point.
all the line of action of forces are meeting at one single point, right?
Yes, sir.
So rotational effect is not possible in such case. Only translation of object is possible. There is no rotational effect. You are here, that is why it is written. Whenever it is mentioned, concurrent force system, already the value of moment is 0. So that only translation is possible means you can use summation of fx equal to 0 and summation of fy equal to 0. Only two conditions of equilibrium exist for coplanar concurrent. Next type of force system you come for coplanar non-concurrent force system. See, whenever non-concurrent force system comes, which is one more added condition over here, which is the added one more condition,
Moment.
Moment.
moment equal to 0. Okay, so because we have mentioned coplanar, we should use only summation of fx and summation of fy, xy plane. We have taken xy plane. We should not write summation of fz equal to 0, right? Why we should not write summation of fz equal to 0 here?
Because it is coplanar.
Because it is coplanar. Only one single plane we have considered, that is xy. Okay, so coplanar non-concurrent force system. These are all the conditions. When it comes to parallel force system, sum of all the forces and sum of all the moments equal to 0. Two conditions. When it comes to non-coplanar force system, and here it is not mentioned whether it is concurrent or non-concurrent. Non-coplanar, whenever it comes to how many translational possible equations? 3. Summation of fx, summation of fy, and summation of fz equal to 0. So under this case, non-coplanar, if it is concurrent, this should not be written. Under the case non-coplanar, if it is concurrent, non-concurrent, this should be written. Got it?
Yes,
Okay. So these are all the conditions of equilibrium. And before going to free body diagram, if you learn Lamis theorem also, it will be helpful for solving problems on free body diagram, equilibrium, and internal forces. It will include everything in this. Okay. So over here, all of you read this statement, Lamis theorem. Yes, Nitesh.
Yes, sir.
Yeah. Did you go on through this?
Yes, sir. Yes, sir.
Yeah. Can you explain?
So when three forces acting at a point, if it is equilibrium, then it will be proportional to the sign of other two forces. Sign of the angle between other two forces.
Sign of angle between other two forces. See, this Lamis theorem, it is applicable to only concurrent force system. Concurrent. It is not applicable to non-concurrent force system. Got it? See over here, three forces are given: P, Q, R. This is a concurrent force system.
Yes, sir.
Yes. So it is applicable to concurrent force system, and provided that what is the condition? Which are in equilibrium. If there exist three concurrent forces which are in equilibrium, then the ratio of magnitude of force to the sine of angle between other two force is constant, or they are proportional. That means P divided by sine alpha. What I said, the ratio of magnitude of one single force to the sine of angle between other two forces. Sine of angle between other two forces is sine alpha, right? So P divided by sine alpha, they are proportional to Q divided by sine beta, and that is proportional to R divided by sine beta. So it is a very powerful tool or formula where it will simplify so much of difficult steps to solve the problems. Okay, P by sine alpha equal to Q by sine beta equal to R by sine gamma. All of you remember this formula with sketch. Okay, P by sine alpha, R by sine gamma, Q by sine beta. So this is Lamis theorem. I repeat the statement. Lamis theorem says, for whenever there exist three concurrent forces which are in equilibrium, the ratio of magnitude of one single force to the sine of angle between other two forces are proportional to it. Okay. Now you come for free body diagram. Jay Surya. Jay Surya, are you there?
Yes, sir.
Yeah. Free body diagram. What is the definition? What normally we write in free body diagram?
Sir, we assume that the mass is concentrated at a single point.
Sorry, come again.
We assume that the mass is concentrated at a single point.
Okay. Okay.
We write the direction of the forces and their magnitude.
Okay. Nisarga, free body diagram. What does it mean?
So which represents the forces. Then also, I mean, the weight we considered in the vertical direction.
Okay. Okay. So free body diagram is that diagram where we free the object with all the connection with other surfaces. Okay, we free it first. See, for example, see this object which is resting on this surface. So while writing free body diagram, we free this object from this surface and we will just show the reaction which is developed by this surface. And we also free this object with the connected cable and we'll just show the force which is acting to that and also weight component. So free body diagram is that diagram where all the forces which are acting on an object including the self weight, and we will free this object with all contact surfaces. So that diagram we call it as free body diagram. Okay. So that is the definition of free body diagram. And one simple example you see, there is a roller which is resting on a surface and connected by a cable. Okay. So this is the free body diagram. Vertically towards down, weight component is acting, and at this surface, a normal reaction R is developing, and tension force is developing in the cable. So this is the free body diagram for this object. Okay. So totally, these are all the components we shown here: tension force in the string, self weight of the object, and the normal reaction developed perpendicular to the plane surface. Okay. Yeah. See this one. Observe what are all things we have written here. So this is the object which is hung by a string and which is resting on this surface. So horizontal reaction will develop in this direction. That is R, which is shown here. And then tension force which is developed in the cable. It is shown here. And self weight will act towards down. Any doubts in writing free body diagram like this?
No, sir.
Come for solving problems. So all of you once again remember the Lami's theorem, conditions of equilibrium. So conditions of equilibrium for coplanar concurrent force system. How many? I repeat, coplanar concurrent force system. How many conditions of equilibrium? 2. Okay. And Lami's theorem, P by sin alpha, Q by sin beta, R by sin gamma. Rather than mugging up this formula, you just remember the definition, that is the ratio of magnitude of a single force to the sine of angle between other two forces are proportional to each other. Yeah. You can have a look on this problem. Two cables are connected at A and B as shown in figure. A force 30 kilonewton is applied at point C. So you will have to determine the forces developed in string CA and CB. So all of you have a look on this problem statement and the sketch. So this is the string or the cable. Cable is like this. At point C, there is 30 kilonewton forces. Direction of this AC is at an angle of 30 degree with respect to horizontal. Direction of this CB is at an angle of 45 degree with respect to horizontal. Are you observing?
Yes.
Now, at point C, you write free body diagram like this. So, what type of force will be there in this CB and CA? It will be compression force or tension force?
Tension force.
It will be tension force, right? Because it is cable. It will be tension force. So, tension force, so how the direction should be? It should be away from the joint or towards the joint?
Away.
away from the joint. So we have named a TCB, tension force in cable CB, and we have named a TCA, tension force in cable CA. Okay. So it is given 30° over here, remaining angle is 60° with reference to vertical. Here it is given 45°, remaining is 45°. And vertical force is 30 kN. So totally how many forces are here? Janardhan Chari?
Yes, sir.
Totally how many forces are here in this free body diagram?
3, sir.
3 number of forces are there.
Yes, sir.
So are they concurrent forces?
Sir?
What type of force system this is? Are they concurrent or non-concurrent?
Concurrent, sir.
Concurrent force system. Are they coplanar or non-coplanar?
Coplanar.
Coplanar. Is it possible to apply Lam's theorem for this?
Oh, yes, sir.
Yes, it is possible. See over here, by looking at this sketch, simplified sketch, this 60 plus 45 is 90 plus 30 is 120, 90 plus 45 is 135. So by looking at this sketch, by applying Lam's theorem, you tell me the expression. What I should write? 30 divided by?
105.
Yes, correct. TCA divided by?
135.
TCB divided by?
120.
Yes, very good. So by applying Lam's theorem, we get TCA divided by 1 sin 30, 135, TCB divided by sin 120, 30 divided by sin 100. So at once, you should take only two components. You take these two components, that is TCB by sin 120 equal to 30 by sin 105. You just do the cross multiplication so that you will get TCB. So once you are done with TCB, you can use only these two terms, that is TCA by 135 and TCB value already it will be there, you substitute divided by 120 so that you will get TCA. Only two steps. Any doubts in this? Have a look. Have a look on this and explanation, solution. If you have doubts, you can ask. Okay. So I hope there are no doubts. Shall we solve this problem? This one?
Yes, sir.
Yeah, read this problem, all of you. A string ABCD, this is a string ABCD attached to two fixed points A and D. Is it visible? Screen is visible or it is too small? Letters are too small.
Visible.
Visible. A string ABCD attached to two fixed point AD and has equal weights 500 Newton at B and 500 Newton at C. Okay, the weights rest with portions AB, CD inclined at an angle of 30° and 60° with respect to vertical. Find the tension force in AB, BC and CD and also the inclination of BC with respect to vertical. The inclination of BC also it is given over here, that is 120 with respect to vertical. Okay, so we'll have to determine TBA, TBC, TCD. Any doubts? We'll have to determine TBA, TBC, TCD. So first, draw a free body diagram at a joint B. So when we consider joint B, vertical force 500 Newton force, and then tension force in this cable, you name it as TBA, tension force in this cable, you name it as TBC. And then angle, it is already given 120 degree in the problem statement itself. So that remaining angle will be 180 minus 120, that is 60 degree. Okay. And here 30 degree is given, the alternative angle. This will be how much? This angle, it is also 30 degree. So remaining angle will be 180 minus 30 is 150. Okay. Yeah. Ruchita, totally how many forces are here?
Sir, 3.
3. So can we use a Lamis theorem?
Yes, sir.
Yeah. So according to Lamis theorem, can we say the expression? Any expression for this?
TBA by
Yeah.
sine 60
Correct.
and 500 by 150
Sine 1
sine 150.
equal to,
Then TBC by sine 150.
yes, exactly. Good. So that is what the expression is. So after writing this expression, TBA by sine 60, TBC by 150, 500 by sine 150. So only you use two terms, that is TBC by sine 150 equal to 500 divided by sine 150. So that you will get the value of TBA 866.03. Okay, use this value or here, and then you compute only these two. So at once you should use only two terms. So we are done with TBA. So if we come to original figure, so we are done with TBA and TBC. We'll have to determine TCD, right? So what we should do now? Tanmay? Tanmay? Are you there, Tanmay? Okay. So draw free body diagram at point C. So at point C, whenever it comes to TBC is there, TCD is there, and then 500 Newton force. So here, this is TCB, TCD, 500. So 500 is known, TCB is known. Only the thing is TCD will have to determine. Again, you apply Lamis theorem at this joint, you will get TCD. See here, the solution part. TBC, TCD, 500. TBC by sine 120 equal to TCD by sine 120 equal to 500 by sine 1. So TCD, only these two terms first you use. TCD by 120 sine 120 and 500 by sine 120. You will get TCD 500. So like this, a different system of cable with different forces or weights, and sometimes angle will not be mentioned in the figure. You may be asked to determine the angle. To be in equilibrium, the given cable system, what should be the direction of cable CD? See over here, this 60 degree may not be given sometimes. It may be mentioned as theta. You may be asked to calculate to be in equilibrium for this cable system, what should be the direction of CD? That would be the question. So such kind of question may be asked. You can prepare for that. Yeah, topic you come for. So we are done with how to draw free body diagram for the cable system and how to use the how many number of equilibrium conditions are there for concurrent coplanar force system. And we did not use this equilibrium conditions for non-coplanar, coplanar non-concurrent force system, right? Okay, that also I'll show in support reaction problem, that one. Internal forces in the structure, just now we did, that is the axial forces in the cables, we determined. So now I will show you this equilibrium equation for non-concurrent forces. Yeah. See here, one simple example. So what type of force system this is, Jaisurya?
It's a parallel coplanar.
Parallel coplanar. Is it concurrent? Is it concurrent?
No, sir.
It is non-concurrent force system, right? See here.
Yes, sir.
Coplanar non-concurrent force system. They are lying in single plane, 6 kilonewton, 2 and 5 kilonewton. Support reaction at A, support reaction at B. All these are reactions as well as forces are lying in single plane, so that coplanar, and they are not meeting at one single point, that is non-concurrent. So how to use the equilibrium conditions under this case? So how many conditions of equilibrium will come in this? Coplanar,
3.
non-concurrent. Jaisurya?
3, sir.
Which are all?
Summation fx is 0, summation fy is 0, and summation of moments is 0.
Moment equal to 0. These three conditions we'll use for solving problems. So the question is like this: a simply supported beam of span of 5 meter is loaded as shown in figure. Find the reactions at A and B. You will have to find vertical reaction at A, vertical reaction at B. Okay. However, it is not clearly mentioned whether it is hinged or roller. Let us take it as a simple force. However, there is no horizontal force, not necessary to worry. So free body diagram, reaction at A, reaction at B, and all vertically downward forces. So first condition of equilibrium, that is the summation of Fy equal to 0, you can use. So reaction towards up Ra and Rb towards up positive, -6, -2, -5 towards down equal to 0. So first equation you will get Ra plus Rb equal to 13. And then another condition of equilibrium, moment at any one point equal to 0 you can use. So moment about A equal to 0 you can use. Ra into distance is 0. So this is 0 rotational effect. 6 kilonewton into 2 meter, trying to rotate in clockwise positive. 2 kilonewton into perpendicular distance is 3 meter, trying to rotate in positive, clockwise direction positive. 5 kilonewton at a distance of 4 meter, trying to rotate in clockwise direction positive. Rb towards up and perpendicular distance is 5 meter and trying to rotate in anti-clockwise direction. So that is negative. Okay. So it is minus Rb into 5, 6 into 2, 2 into 3, 5 into 4 equal to 0. So you will get value of Rb as 7.6. Okay. So by using these conditions of equilibrium assumption of Ma equal to 0, we got value of Rb. So substitute this value over here in this equation, you will get Ra equal to 5.4. This is one simple example for the analysis of coplanar non-concurrent force system, which comes under equilibrium condition. Okay. So in these cases, if they have given different force system like a uniformly distributed load, so in such cases, you will have to convert this uniformly distributed load into point load. This is 10 kilonewton per meter. UDL is given. 2 meter span is there. So 10 into 2, that is 20 kilonewton, which will act exactly at mid span of this 2 meter. So you should do that. And then same procedure, summation of Fx, summation of Fy, summation of M equal to 0. You can see one case where force is inclined and support is also inclined. So when the force is inclined, you resolve this into vertical and horizontal, 100 cos 45, 100 sin 45. And then you convert this UDL into point load, 50 kilonewton per meter, 3 meter, 50 into 3, 150 kilonewton at 1.5 meter per D. And then over here, you show reaction D, that is RD. And here the slope is given 1:2, 1 vertical, 2 horizontal. So that this theta inclined angle you can determine. Tan theta equal to 1 by 2 opposite by adjacent. So that theta you will get. So this RD you can resolve with respect to theta, so that RD cos theta RD sin theta you will get, and you can determine the unknown reaction RD and R. So this is what with respect to equilibrium condition for coplanar concurrent and coplanar non. So this is also here. So totally system of force, it is clear. How to draw free body diagram for cable structures we saw, and some problems on that. Equilibrium equation for coplanar concurrent and non-concurrent force system we saw, and internal forces in the structure, that is actual forces in the members, we are done. Now you come for next topic, frictions and its applications. Okay. So all of you know what is the reason the frictional force develop in between the surfaces, right? Whenever there is a rubbing action takes place, why the frictional force will develop? Basically, what does it mean? Frictional force definition, Pranati. What is the definition of frictional force?
So it's the resistance offered by the surface
Yeah. When? Under what circumstances?
when either when it is stationary or when it is moving. In both the
Yeah.
cases.
Whenever there is a rubbing action takes place between two surfaces, basically. Okay, fine. Whenever there exists some rubbing action between two surfaces, the resistance against the moment of that object is offered uh, in the direction tangential to the direction of the surface. So that resistance force is nothing but frictional force. So this frictional force will develop due to the irregularities on the surface, and also there may be molecular attraction between the particles which are there in the different materials. Okay, this is why the frictional force will develop. So in our mechanics subject, we'll discuss about dry friction. So before going to that, limiting friction and coefficient of friction, we need to be aware of. See, the magnitude of a frictional force, for example, I have kept a block on a table. I'll apply 5 Newton of force and the object is not moving. Under this case, what is the magnitude of developed frictional force? Nisarga? Nisarga? Can you hear me? Okay. Chandana?
Sir?
Can you hear me?
Yes, sir.
Yeah. I have kept a block on a table
Yes,
and
sir.
I will apply a 5 Newton of force on the block. The block is not moving at the state of rest itself. So now tell me, magnitude of frictional force.
No, sir.
Sorry? Hello?
Hello.
Can you hear me, Chandana?
Yes, sir. Yes, sir.
So I have kept a block table.
Yes. Yes, sir.
I will apply 5 Newton force horizontally.
Yes, sir.
Block is not moving.
Yes, sir.
What is the magnitude of frictional force developed now between the table and the block surface? Niteshian.
Yes, sir.
Yeah. How much frictional force will develop?
5 kilonewtons.
5 Newton only, right? Not kilonewton, man. 5
Yeah,
Newton.
5 newtons.
5 Newton only, right?
Yes, sir.
So if the block is not moving means the frictional resistance developed is 5 Newton itself. So you increase to 7 Newton, still the block is not moving means again the frictional force developed is 7 Newton. You go for increasing 10 Newton, still the block is not moving means frictional force developed is 10 Newton. Okay, you keep increasing and the block will reach a point where block will it will reach the position where it is about to move. It is about to move. For example, 12 Newton you will apply. So 12 Newton also it is not moving. But if you increase 12 to 13, block will move. So that maximum frictional force which will develop and which will not allow the block to move or object to move, that frictional force is termed as limiting frictional force. So if you exceed this limiting frictional force, the body or the object will start to slide on other surface. Next you come for coefficient of friction. So you see this figure, there is a block which is resting on some surface. So if you write a free body diagram, a normal reaction from the surface, and if you apply P force, a frictional force will act in the opposite direction to the applied force, or the object tending to move in the direction to the direction of in the opposite direction, this frictional force will develop. So this is F, this is N. Okay. So here tan phi will be equal to F divided by N. So tan phi will be named as mu, that is coefficient of friction. So mu equal to this F divided by N. So that mu is known as coefficient of friction. So it is the constant ratio which will relate the limiting frictional force and the normal reaction. This is the limiting frictional force and this is the normal reaction. So basically coefficient of friction is the ratio of limiting frictional force and the normal reaction. So there are different types of frictions are there, static friction and dynamic friction. And dynamic friction is subdivided into sliding friction and rolling friction. Okay. Some of the laws of friction, it is important to know. Normally, you may expect questions from that laws of friction. All of you have a look over here. So, what is the direction of friction? It will always develop in the opposite to that in which body tends to move. This is the direction of friction. The magnitude of force of friction is exactly equal to the applied force which just moves body. I explained already this one. The magnitude of limiting friction bears a constant ratio. There is nothing but coefficient of friction. That is mu equal to F by N. The force of friction, it is independent of area of contact. See, all of you remaining things you will remember and you will write. But normally one thing you will forget, this one. The force of friction is independent of area of contact between people. You may feel like more surface area is in contact with other surface, more friction. If less contact area is there, less friction, you may feel like that. No, it is not. So frictional force, it is independent of area. The force of friction depends on the roughness of the surface also. Okay, these are all the laws of static friction. In the same manner, same laws applies, but where it is in moving condition. So one simple problem, let us try to solve whether the block will move or not. Read this problem statement. A block shown in figure is just moved by a force 200 kilonewton inclined at an angle of 20 degree with respect to horizon. Okay, the weight of block is 600 Newton. Determine the coefficient of static friction between the block and the floor. See here, there is a block. This is resting on horizontal floor. The weight component of this block is 600 Newton, and it is pulled with an inclined force 200 Newton at an angle of 20. So you can write a free body diagram for this. 600 Newton force towards down, 200 Newton force at an angle of 20 degree. Normal reaction is towards up, and frictional force towards left. Why it is shown towards left? Because frictional force will develop in opposite direction to the direction of tending direction of object. Now the question is, we will have to determine the coefficient of static friction, that is mu. So what is mu? Just now we saw that, right? What is the mu is the ratio of limiting frictional force to the normal reaction, that is F divided by N is. So summation of Fx equal to 0, first condition of equilibrium you apply. So forces in horizontal direction is 200 cos 20, and then towards left mu into N. So mu N equal to 187.938, you will get equation 1. Summation of Fi equal to 0 you apply, towards down 600, towards up N, and then also one more vertical component is there, plus 200 sine. All these components you take, to do so you will get N. N you substitute over here, you will get value of mu. The value of mu over here is 0.35. So that is the coefficient of static. And there may be some questions like a comparison between a coefficient of static and kinetic friction. So which will be more in magnitude? Static friction will be greater or kinetic friction will be greater? Surya? Yamuna?
Sir,
I said the two types of friction, static and
dynamic,
kinetic.
kinetic,
When the
sir.
object is moving. So which friction force will be greater? Static will be greater or kinetic friction will be greater?
Sir,
Magnitude. Kinetic friction magnitude will be greater or static friction magnitude will be greater?
kinetic, sir.
Kinetic. What may be the reason?
Sir,
Okay, no issue. See, whenever the object is at the state of rest, so it will be having a firm contact between the surface and the object. So there will be better interlocking between the object surface and the block surface or any object surface. So it will take a more energy or more force to move it. But when the object is moving, then the interlocking effect will be quite less. So kinetic friction value always will be lesser than the limiting frictional force. That limiting frictional force is nothing but static friction only. Okay, so here one simple problem we saw how to calculate the coefficient of friction. Let us see one more problem whether the object will slide or not. There is a block of mass of 20 kilonewton which is placed on an inclined plane. An inclined plane at an angle of 30 degree with respect to horizontal, and it is subject to a force P that is parallel to the plane. Taking the inclination with respect to horizontal 30 degree, coefficient of friction as 0.24, we'll have to determine the value of P for impending motion of the block. So what is the impending motion of the block? Impending motion of the block means What does it mean? Impending motion means? Pranati?
So it's the motion it's supposed to move in, or it's
About to start motion. The state of the object which is about to start its motion, at the verge of its motion. You can say that as impending motion. Okay? Yeah.
Yes, sir.
Yeah. So there exists, they have not said what should be the direction of motion. There may be two cases over here. So what is the least value of P so that object, this block resting on inclined plane, about to move towards down, and other cases what is the maximum value of P so that object is will reach a point where it is about to move towards up. Two cases are there. For both the cases, let us see how to determine value of P. So first case, what we see over here. So what is the least value of P so that this block is about to move towards down? Least value of P we are talking about. So move towards down means friction will develop towards right, and weight component is 20 kg block they have said, right? So 20 into 9.81, so that in terms of Newton you will get. And normal reaction will develop towards y direction, that is perpendicular to this incline. So this one you use conditions of equilibrium, summation of Fy equal to 0 and summation of Fx equal to 0. If we use a summation of Fy equal to 0, you will get value of n. So 20 into 9.81 cos 30 towards down, and then normal reaction n towards up, you will use n value you will get. And summation of Fx equal to 0, the horizontal component of this 20 9.81 multiplication with sin 30 and mu n will get, so that you will get value of P. So this is the least value of P so that this object will reach a position where it is about to move towards down. And another case is second case. So what is the maximum value of P so that object is about to move towards up? So see the direction of frictional force. It is shown towards left direction. So object is about to move towards up, right? So in free body diagram, the direction of F is shown towards left. So use same equation, summation of Fy equal to 0, summation of Fx equal to 0. So value of n you will get and value of P you will get. So this is the maximum force which is required to bring this system where it is about to move towards up. We compare this value 138. So it should be obviously greater than case 1, that is 57.321. Okay. So this is what some more problems you can practice on friction, and then center of mass and free vibration. When it comes to the center of mass, you have like so many problems you have solved on center of in finding the centroid. So in understanding center of mass in association with the center of gravity and centroid. So let us see what you mean by center of gravity. So if you take one object, center of gravity is a point about which, for any orientation of the body, the resultant weight component of that object will pass through. Okay, that point we call it as center of gravity. So the net resultant weight of the body will pass through that point. Okay, so here also we'll use the Varignon's theorem. That is, moment of resultant force will be equal to moment of individual weight components about the same point. And in case of mass, it is independent of gravity component over here. In place of weight component, will use mass component, and moment of mass we will divide with overall mass. By using that, we will calculate the location of center of mass for a particular object. In case of a centroid of a volume, in place of weight or mass, we will use volume, and we'll take moment of volume and we'll divide that by total volume. So same thing it is applicable to area also. So moment of area divided by total area will gives you the centroidal location. Okay. Okay, I think that's enough for today's session. Continuous 2 hours of engineering mechanics discussion. At what time we started? Chandana, Jamuna, Nitesh, Surya.
Sir, around
What time?
6:10.
6:10 we started, right?
6:30 ರೆಕಾರ್ಡಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರಿ ಸರ್.
Recording 6:30 ಆಗಿದೆಯಾ?
ಹೌದು ಸರ್.
Okay, fine. Yeah, let us see some more 3 minutes of discussion. Let's have more discussion. Okay. So whenever it comes to composite bodies, finding out the centroid. For example, the sketch is given. This is the cross section. So in this cross section, what normally we'll do is we'll divide this into one rectangle like this and 2 triangles, left side one, right side one. So x bar, however, it can be located because it is symmetric exactly on y-axis it will come. But for locating centroid with respect to horizontal base, so each individual areas we should take moment about the base. Okay, so triangle will take moment. This triangle also will take moment about base, and one rectangle also will take moment about base. So after taking moment of all the individual areas about the base, we will divide that by total area. So one simple example for finding a centroid of plane areas. Simple example problem. Let us see. So for the standard plane figures, you need to remember, for example, if it is a rectangle, the centroid is located at a distance of b by 2 from one face if it is a total width is b, and at a distance of d by 2 if the height is d from the base. And when it comes to triangle, if it is symmetric about a vertical axis, with reference to this point, the x bar is b by 2 and y bar is d by 3, 1/3 of height from the base or 2/3 of height from the apex. However, the location of centroid won't change. Only the coordinates with respect to which point you will measure that distance matters. Okay, in case of right angle triangle, 1/3 of this base distance, 1/3 of this height. And then for a circular lamina, it will lie exactly at center. For a semicircular lamina, if you write a semicircle and y-axis, if you consider here, its radius is the x bar and 4r by 3π is the y bar. If you consider y-axis over here only, x bar value will be 0. You can change the axis. And when it comes to quarter of circle, it is 4r by 3π from y-axis, 4r by 3π from x-axis. So those are all the standard formulas you need to remember. So one T section, let us see how to calculate a centroid for this T section. So it is symmetric about y-axis. If we draw y-axis here, x bar value is 0. But if we draw y-axis here, x bar value is not 0. X bar value is this. From center of this to here we should measure, that is 120 by 2, that is 60 is the x bar value. Okay, it depends on where exactly you will show the axis. And with reference to this line, if you want to locate y bar, both the areas you should consider. So rectangle 1, this one we have taken, rectangle 2, this one we have taken. 120 120 mm is the width, 10 mm is the height, 60 mm is the height, and 10 mm is the dimension of rectangles. So rectangle 2, it is started with area of rectangle is 10 into 60. So that is 600 mm square. And rectangle 1 is 120 into 10. That is a 200, 1200 mm square. Area of rectangle 1, area of rectangle 2. So now you come for individual centroidal distance from the base. When it comes to this rectangle, with reference to this base, it is half of 60, that is 30. Centroid of this individual rectangle with reference to this base is 30 mm. So that is what it is written over here. So centroid of rectangle 1, it is somewhere over here. Distance of this from base is 60 plus 10 by 2, totally 70. So, sorry, 10 by 2 is 5, totally 65. It is written over here. So that is y1, y2, this is y1, this is a1, this is a2. Now we'll have to take a moment of this area, right? This area into centroidal distance is, that is perpendicular distance, that is nothing but a1, y1, a2, y2. 600 into 2, 1000. Okay, 600 into 2, that is 1000. It is not 2, it is 30. 18,000, 1,200 into 65, 78,000. Now summation of AI, YI you should take. Okay, that is 96,000, and summation of areas also you should take, that is 1,800. So finally y bar you will get y bar equal to summation of AI, YI divided by summation of A. You will get 53.33 mm is the y bar with respect to base. So centroid is located somewhere here at a distance of 53 from here. So this is how to locate the centroid for composite plane figures. However, for standard plane figures, you have standard formulas. You can use those standard formulas and you can determine the centroid. Just a minute, I'll take attendance. I'm taking a photo for attendance. And I'll stop recording also. Be in line.